Hey folks, in today's class I'll be talking about the momentum. So momentum is an identity which is represented with symbol P and with a vector on top. And if I look into the definition of momentum, it is equal to product of mass and velocity. That's what momentum is. Now, if I look into the units of momentum, we can always design the units from the formula. It is equal to mass unit is kg and velocity is meters per second. So the momentum units will be equal to kg meters per second. Now, if I look into the physical definition of momentum, momentum has no physical definition, no, oops, physical definition. It has only mathematical definition, which is mass times velocity. Now, momentum, if you see with the momentum, I'm drawing this arrow on top. This arrow tells me that this is a vector quantity. When we talk about the vector quantity, it means it has some kind of a direction associated with it. So first of all, I'll talk about the direction, which one will consider as positive, which one will consider as negative throughout this course. So this is east, this is north, this is west, this is south. East we consider it as positive, north we consider it as positive, west we consider it as negative, and south we consider it as negative. Now, if a car is moving in the north direction and the mass of the car, let's suppose, is 1000 kgs, and the velocity with which it is moving is 5 meters per second. I wanted to find the momentum. So momentum value will be equal to mv, which is 1000 times 5. And this, again, this is velocity, so I have to specify the direction also. For the sake of this question, I'm going to consider it as east direction. And east we consider as positive, so I will keep this number as positive, and the momentum value will be 5000, and the units will be kg meters per second. So that's the momentum. Is it the complete answer? No, because I haven't specified the direction. So the complete answer will be equal to P equal to 5000 kg meters per second, and the direction is east because that's a positive number. Now, if the same car is moving in the west direction, how I'm going to solve this question? So I'll encourage you guys to pause the video and try to solve yourself and then match the answer. So mass is 1000 kgs and velocity is 5 meters per second, and this is in west direction. So the momentum value will be equal to mass times velocity, which is equal to 1000 times 5, and this is in the west direction, so I'll mark it as negative. So this will be equal to 5000 negative in kg meters per second momentum. Now negative 5000, I can also write it as momentum equal to 5000 kg meters per second in the west direction. So hopefully you're clear about what momentum is. Now, the second thing which I'll talk about is change in momentum. Change in momentum. Change in momentum is equal to P final minus P initial. Kind of a difference, you can say. Now, change is also represented with this symbol. This delta symbol means change. Delta P is equal to P final minus P initial. Now, I'm going to take an example here. If there is a car, this car, again, same 1000 kg, is moving with 5 meters per second in the east direction. And then after 10 seconds, it's moving with 10 meters per second in the same direction, east. I wanted to find out what is the change in momentum. So delta P is equal to P final minus P initial. Now, what is the P final? Momentum value will remain the same. The formula for momentum P is equal to mv. That's what we said. So again, I'm going to keep elaborating on this formula. And this is m times velocity final, because this is the final momentum, and initial momentum is product of these two quantities minus m v initial. And mass of the car is not changing. And if the mass is not changing, I can take it outside and I can write it as v final minus v initial also, which is equal to change in momentum. And now 1000 times v final, which is 10 minus initial value, which is 5. And then if I multiply 1000 times 5, that's going to give me 5000. Notice this number comes out to be a positive number. So if this is a positive number, it means the car is moving in the east direction. So let me write down the units also, kg meters per second. So delta P, change in momentum, is 5000 kg meters per second in east direction. Okay, so from here we've generated another formula, which is change in momentum is equal to mv final minus v initial 2. So you can use any formula. You can use this one or this one, whatever formula you want to use depending upon the given question. Now let's look into a little more complex problem. So if this is a car which is moving in the east direction, again same 1000 kgs car moving at 10 meters per second in the east direction. But after 15 or 20 seconds, you observe that the same car is moving in the opposite direction with the speed of, let's say, 5 meters per second. So opposite direction means it is moving in the west direction. Now, I wanted to find out change in momentum. So how I'm going to approach this question. So change in momentum will be equal to m v final minus v initial. Now, final velocity in this case is 5 meters per second, but this is in the west direction. So if it is in the west direction, so I have to place a negative with it. So negative 5 minus initial velocity, which is in the east direction. So I'll keep it as positive. So 10, this negative sign belongs to the formula. So it does not say that this 10 is negative. 10 is a positive number. So I'll write it like this so that you don't have any confusion. Now this will be equal to negative 5 minus plus minus will become minus 10, and then mass value is 1000 kgs, and this is 1000. So 1000 times negative 15, which will be equal to, which is equal to delta P, and this is negative 15,000 kg meters per second. Now change in momentum, delta P, is equal to 15,000 kg meters per second in the west direction. So hopefully you're clear about some of the basics of momentum. Now, again, I'm going to keep on elaborating on this one. We did the formula that change in momentum is equal to P final minus P initial. This is the one formula which we did. Another formula we also wrote down, change in momentum is equal to M V final minus V initial. This is another formula we write down. Now what I'm going to do is I'm going to try and find out the relation between force and momentum. Relation between force and momentum. So if I look at the force formula, force is equal to mass times acceleration. That's what force is. Again, this is a net force. A lot of people confuse themselves. This is a net average, shall I say, net average force. Again, if you are confused about what is net average force, I will recommend you to look into my other physics lectures where I've explained it in detail. What is the difference between force and net average force? Now this is equal to mass V final minus V initial divided by time. This is acceleration. Again, this acceleration is also average acceleration. Now, final velocity. Again, if I open this, I can write it as mv final minus mv v initial divided by time, and this is force net average. And then I can move this time on the other side. F net average multiplied by time, which is equal to mv final minus mv initial. Now this is equal to what? This is final momentum, P final minus P initial. Now F net average multiplied by time. So this is in turn equal to change in momentum. So F net average times time is equal to change in momentum. So that's another formula which we derived from here. Now I'm gonna add this formula to these two formulas. So change in momentum can also be represented as F net average, F net average times time. Sometimes in some of the books you will see it as F net average times delta t, which means one and the same thing. This basically means this time, or delta t means the time of the span of the time across which that force is being applied. So this is another relationship between for the change in momentum. Now one more final formula which I wanted to give you. The real definition, if you wanted to look into the change in momentum formula, which I prefer, is change in momentum is equal to area under force time graph. Force time graph. Now, why I use this definition and why I prefer this one? Because if I look into the previous one, in this one there is a constraint that this is only talking about the net force. So if I try to draw the area under force time graph for this formula, I must draw average force. Average force means it will be an average force, a horizontal line. And if it is happening over this span of time, so this will be delta t. And then I can write down the formula from here also, that this is equal to uh, area of a rectangle. So force, this is the force, amount of force which is being applied, and over a span of this time. So force average and times time, which is equal to delta p. Now, what if the graph doesn't look like this? Means if you have the force which is varying across the time span. So something like this, if you have a graph like this, and which is more of a real life problems, this is what happens. So force is represented here. So in this case, there will be a peak force, isn't it? The force maximizes at this point, F peak. And this whole incident is happening over a period of this time, delta t. Now, area under the graph, as I said, I prefer this definition. According to this definition, this becomes a triangle. So for a triangle, I can call it as area of a graph is half times this height, which is F peak, F peak, peak force multiplied by time, or change in time. So this is change in momentum. So if you notice, the formula changes. Now, if I can learn this definition, if I can try and solve all the questions by using this definition, area under the graph, then I don't need to memorize any formulas. You know, I will always look into what kind of an area I've been given, and then I can apply the formula. If it is a rectangle, if it is a square, or whatever different kind of areas are given, and I can just apply those formulas and can get the answer. So hopefully you got some information about momentum, so, and the change in momentum. So that's about it for today's class. If you like it, then think of subscribing it, and Thank you very much. I'll see you in another video. Bye.